A drop jump is a vertical jump or hop often used in the assessment of the lower extremities' power and stiffness characteristics. It is an aggressive, eccentric, concentric muscle action which is specifically characterized by the involvement of short-range elastic stiffness and automatic reflex neuromuscular actions superimposed to the voluntary control. This stretch-shortening cycle test involves a primary action of the ankle plantar flexors and of the knee extensors, although it is a whole-body action that also requires good core stability. Based on the parameters derived from the ground reaction force and flight time, the dynamics of this elementary movement pattern can be thoroughly studied. The subject performs a jump where he or she drops down from a specified height and then jumps upwards as fast and as high as possible. Enter the Drop Jump Test module from the main window by clicking on the Drop Jump button. Make sure you have acquired the subject's body weight beforehand. Consistently with the organization of all the MARS test modules, the interface is divided into a left setup panel, a right analysis panel, a bottom measurement panel, and the central signals and results area. Before starting the measurement, appropriate input parameters must be determined in the setup panel. These are lower extremities, where you can choose among the following: bilateral jump, jump with the left leg, or jump with the right leg, and upper extremities, where you can choose among hands positioned on the hips, freely positioned, crossed over the chest, or positioned behind the neck. Drop height, where you can choose among different heights. To start with a measurement, click on the New Measurement button. After launching the test module and clicking New Measurement, initialization and offset takes place. During this time, the subject should not be on the force plate. If necessary, the measurement mode can be cancelled by pressing the Cancel button. Before starting the measurement, the subject must assume an appropriate initial position, that is, standing on a lifted platform, for example a bench, with knees, hips, and torso extended and eyes directed to the front. The goal of the task is to drop from a lifted platform on a force plate and then produce an explosive vertical jump as fast as possible with amortization in the knees and hips. Initiate the measurement by pressing the Start button and instruct the subject to drop on a force plate. The landing after a drop must be performed on extended legs with some degree of plantar flexion. This might vary depending on the specific technique. However, the subject in all cases tries to make the most explosive hop possible, which is achieved by making short, aggressive contact with the ground and by preventing the drop of the heel. The hop should be done following the principle of shortest contact time and highest jump height possible, both together. The landing after the hop must be performed on the force plate as well. While landing, the very first contact has to be performed with extended legs and feet in plantar flexion. This is then smoothly followed by a normal amortization of the lower extremities. The measurement stops automatically after the second landing. It can also be stopped manually by pressing the Stop button in the lower panel. The measurement can be repeated by clicking on New Measurement, thus not saving the previous repetition. If you are satisfied with the measurement, you can save it. The central window displays the ground reaction force signal measured by the force plate. Markers are positioned automatically on the most relevant spots used for analysis. The first contact is marked by the Start cursor and is identified by a steep increase in the ground reaction force profile. Takeoff and landing can be easily identified by the moment when the ground reaction force falls to 0 and starts to increase again. The cursors positioned on Start, takeoff and landing can be manually adjusted. Other cursors are adjusted automatically. If again automatic positioning is required, click Analyze, and the cursors will be repositioned according to your settings specifications. If the cursors are repositioned, the new analysis can be saved as a new measurement by pressing Save. Under the V-Drop Height tab, you can find the graphical presentation of the relationship of the normalized vertical takeoff velocity to the drop height. If the subject has performed the test from different heights, then you can observe the trend of the vertical takeoff velocity from different heights. For example, in our case, the subject has performed the test from 30, 50, and 70 centimeters. The data from the analysis can be viewed under the Results Table tab. The results parameters are divided into three main groups. General parameters. These include different velocity, acceleration, force, power, and work parameters. Additionally, various time profiles and force impulse parameters are calculated. A more thorough description of the parameters can be accessed by right-clicking on the parameter name. Options for displaying specific sets of parameters can be accessed under the Parameters View menu in the right panel. For more information on this topic, please refer to Tutorial 7.